Hey guys, welcome back. We just finished 8.4 and we're getting ready to do 8.5. So let's do it. 8.5 says, what is the critical value? So we know the critical value is Z star or T star. So let's take a look. What is the critical value for calculating a 94% confidence interval for a population proportion? Okay, so I need a Z star. So we go to the table of B and I want 94%. Okay, so somebody asked, am I going to have to use the T interval on my calculator? The answer is no. So, but let me jot some stuff down here. So I probably wouldn't put a problem like this, but it's good to go over it. You never know what's going to happen on the AP test. So, but I just can't put every possible problem. But I'm going to write the Z score down for a 90 and the Z score down for a 95, right? Okay. So looking at my choices here, and we're expecting it to be between those numbers, and the only one between those numbers is that number, and when we check with the back of the book, we get our answer C. So we didn't really need the T interval anyway, but if we wanted it, that would help us arrive at an exact answer. Okay, let's look at question 8.6. So T 8.6 states, a radio talk show host with a large audience is interested in the proportion of adults listening who are drinking ages lower than 18. To find this out, he posed the question to the listener, do you think drinking age should be reduced to 18 in light of the fact 18-year-olds are eligible for military? He then asked yes or no. So this is definitely a proportion question. Of the 100 people who voted, 70 said yes. So that means that this is my sample proportion or my point estimate. Okay, that's what I kind of jotted down there while I read. So it's a proportion question and it's 100. The sample proportion is 70 over 100. So that's our point estimate. But what do they want to know? Which of the conditions are violated? Interesting. So we know from our notes that on a proportion question, I need random, population at least as large as 10, and large counts. So I know that 70 said yes and 30 said no. So I know large counts is okay. All right. I think the problem's random because people called in. So that's called a convenience sample. So that's kind of a violation of randomness. Random is a problem. Okay, so let's take a look. The 10% should be fine because I want an inference about teenagers. So the large counts we said is fine. So only A. Okay, only that first one. Cool. Let's look at 8.7. So looking at 8.7, a marketing assistant for a technology company. Zoom in here. A marketing assistant for a technology company plans to randomly select 1,000 customers to estimate the proportion who are satisfied. So let me get myself even more room to be able to write so you can see both what I'm writing and what I'm reading. All right. They randomly, I like the random part, right? We got that. Randomly selected 1,000 customers to estimate a proportion. So we got a proportion question. That were satisfied in the firm's performance. Based on the result of the survey, the assistant will construct a 95% confidence interval for the proportion of all customers who are satisfied. The manager, however, said the firm can afford to survey only 250 people. How will this decrease the sample size effect of the margin of error? Oh, what a good question. So when we look at our margin of error, we say to ourselves, our margin of error for a proportion question back in our formula sheet, which we'll have for the test, looks like that. So if I'm doing a 95% confidence interval, then my Z star is this. And if I don't know what they're going to say, I'm assuming this is 0.5 times 0.5, so that's 0.25, all over N. Okay. So we can think of it as if you You could do this and make n equal 1,000, plug in 1,000, and then do it again and make n 250 and kind of compare, see what happens. That'd be one way to do it, not the only way, but. Okay, so I get a margin of error of this. Now let's do it with the smaller number. And again, we should be thinking in our mind, how is this going to change things? So by reducing it, my margin of error doubled. So what is this? Well, you reduced it by a factor of 4 because 1,000 divided by 4 is 250. But that's not a 4, it's a 2. So the reason is because the square root of 4 is 2. So that's why it doubled the width of the margin of error when you reduced it. So now let's make sense of our answer. So 8.7 states the margin of error will be about 2 times larger. We want our answer B, and hopefully you know why. Interesting. All right, 8.8. Ooh, I love these. Okay, super exciting. Let's move my camera here. It's a bit cumbersome with this big hunky book, but I'm trying. 8.8, 35 people from a random sample of 125. So, N is 125. Were admitted using sick leave, were ill, 17 employees from a random sample from company A. Oh, we haven't compared 2 of these. So this question I wouldn't have on the test, but this is cool. This is actually, you could flip back in the notes. So one of the samples, you have a sample A and a sample B. So 17. So the proportion from A was 17 out of 68, and the proportion from B oh wait, 35 people. What the fudge? I can't get this right. Proportion A said 35 out of 125. So, all right, there it is. All right, so looking at our book and back to our formula, we just flip one page over and we're like, oh, okay. So Miss Krusemark might be talking about 2 samples and she decided to reserve that for later. So my 2 sample, do you see how I want my P1 hat, 1 minus P1 hat, P2 hat, add those, put the ends over each other. Okay, that's what we're looking for there. So I'm gonna pick a formula that matches that formula and let's see what we find. Okay. So if I look at those answers, I see that B is a match. So let's take a look. So 35 divided by 125 is 0.28. And 17 divided by 68 is 0.25. And if I subtract those 2, I get 0.03. So that's why I like B. I like that critical value of B as well. That doesn't have a critical value, so that's a problem. So now I've narrowed it down to B and C. And now when I look at this formula, I want to add the 2 numbers. Oop, you can't see anything that I'm pointing at. Sorry about that. I moved my book. So let's look at my calculations here. PA, PB, if I subtract the 2, I get 0.03. So that's why I like B as my choice, A, B, or C. I definitely need plus or minus my z stars, so I gotta have, this one's no good, so there we got this. And again, thinking about the formula I just got done seeing, I need to add the 2 in the middle. So definitely B is our answer. Excuse me, let's look at number 9. So looking at number 9, it states, a telephone poll SRS of 1,234 adults found that 62% were generally satisfied with their life. The margin of error announced was 3%. Does the margin of error account for the fact that some of the don'ts don't have telephones? No, we talked about that in class. So that's counting for just the general variability happening. So on number 9, we say E. No, the margin of error only accounts for the sampling variability. Okay, the other ones are nonsense. All right, last question. Let's look at 8, 10. So at a baseball game, 42 out of 65 randomly selected people owned an iPod. At a rock concert occurring at the exact same time, 34%, or 34, excuse me, out of 52 were owning an iPod. A researcher wants to test the claim that the proportion of iPod owners at the 2 different venues is different. So they pretty much look the same, right? He wants to do a 90% confidence interval for difference. So again, this one won't show up on the test, but again, it's a good question. I don't feel like we're ready to test you on the difference, but it's really just using one more type of a formula. So which of the following gives the correct outcome for the claim? So in fact, this just helps us test this follow-up idea. So the follow-up idea is if there is absolutely no difference, that means it's possible that, let's say they're both 6.5. So if they're both exactly the same, 6.65, then that means the difference would be absolutely 0. So that's why we're looking for, does 0 fall in the interval? Because if it does, then there is no difference between these two numbers. So think if this was the true proportion and this was also the true proportion, we'd assume a little variability. So half the time, whether you're at the rock concert or the baseball game, half the time you might be above and half the time you might be below. So where do we find our answer here? We're looking for whether or not 0 is in the interval. So we've narrowed it down to A and C. So let's take a deeper look here. It says because 0 is in the interval, the researchers can conclude that the proportion is the same. All right, let's take a look at C. Because the interval includes 0, the research cannot conclude that they're different. That's actually more accurate. In fact, they could be similar, but not exact. So maybe this could be the truth, and that's the truth. So just because we found 0 within the interval, we didn't get evidence that they're exactly the same. We just don't have any evidence that they're definitely different. Okay, so this feels like a nuance, but we definitely want to show that C is our answer, and we'll get more into this later. So this won't be on the test, but we will be doing differences for me. So we say, since the interval from blank to blank. So our interval here was negative 0.154 to that. Since the interval includes 0, right? We can't conclude they're different. We captured indifference. Okay, great. Thanks for joining me, guys. Enjoy.